know what I'm gonna be honest, I have no clue what your assignments are at the end of the week. And at this point, I feel like everything's gonna get messed up if we do have the snowstorm, so I'll figure that out tomorrow. And I'll kind of just let you know as we're going. I think that's it. All right, loin. So we talked quickly about slope. We'll kind of rewrite all that stuff down anyways, but it's good to just say like, oh yeah, I kind of remember that, or I've heard of that before, or whatever. Sorry. One day I'll buy curtains for these ones. So it says find the slope of each line. So when we're looking at a line, we are going to say that the slope equals the rise over the run. The big thing here is counting rise over it isn't bad. It's remembering about signs, positives, negatives. That's usually what kind of messes people up sometimes. So as you're counting rise over run, you need to find 2 points. So these ones you can kind of see the points. I'm going to pick one right here and this one right here. Make sure it's going through an exact point, like not like, a little to the right or a little down. You need it to be an exact point. Just like a book, we go from left to right. And you always want to start by going up or down first. Your vertical first and then your horizontal. So please don't move right first. We don't want to do that. We're going to move down and then over. Looks like it makes a nice little triangle there. And then we're just going to count. Just think about your direction. We're going down. 1, 2, 3, 4, 5. Remember, don't actually count this point, right? That's just your starting point. And then you're going down 1, 2, 3, 4, 5. And then I'm going to the right. I'm starting from here. 1, 2, 3. When we think about rise over run, this is our rise, this is our run. But down is a negative direction. So just take that into account. Right is positive. So we would say our slope for this was negative 5/3. So don't write 5/3, don't write 3/5, don't write negative 3/5. It gets all sorts of confusing if you put stuff in the wrong spot. Just take into account what your direction was. Down is negative or left is negative. Up is positive, right is positive. Oh, shnikes. What's this one about? When I think about it from here to here, and I'm talking about rise over run, I'm going up 1, 2, actually, I guess it doesn't really matter, right? 2, 3, 4, 5. So my rise is 5. My run is 0. So my slope is 5 over 0. And if I say 5 over 0, what's actually my slope?
5.
Undefined. Remember, you cannot divide by 0. We talked about that recently. You can't put things in no groups. Anytime you see a vertical line, your slope is always going to be undefined. So something to be on the lookout for. And then this one, all right, pick 2 points. You can kind of see the 2 points there, or there's even a point in between there. You can use that. So as long as it makes sense, we move from left to right to get to that point. I'm going to go up 1, 2, 3, 4, 5, 6. I'm going to move to the right 1, 2, 3, 4. So when I think about my slope of rise over run, that would be 6 over 4, which I can reduce to 3 over 2. If you had noticed there was also a point there, that would be 1, 2, 3 over 1, 2. Magical.
What happens if we start at the other point?
So you went right to left?
No.
You went here to here?
Yeah.
You would go down to the left, so that would be a negative over a negative, which would turn to a positive.
Oh, so it still works.
So it'll still work. That's why I usually just try to go left to right. But it will still come out to the same thing. Just be careful with your signs. Okay, so you guys have a general idea. Okay, slope, how exciting, woo. Just make sure you can look at a graph and tell what the slope is. We will do that a lot as the year goes by. And I teach algebra 2. We do that a lot in that class. It's making sure we know these basics. That's going to be important. And go from there. So now it says find the slope of the line passing through the point. We don't want to have to graph everything. That's a big pain in the butt. So we do have that slope formula, so if you just wanna remind yourself, it's y2 minus y1 over x2 minus x1. Please don't say slope formula and say y equals mx plus b. They are not the same. That's an equation. This is just a formula that we're plugging into. So if you guys can probably get used to this pretty quick, but when you're talking about points, this is x1 and y1. This is x2 and y2. You just kind of throw it in and see what you get. So my slope of this would be 9 minus 4 over 6 minus 3. Once again, if last year you did y1 minus y2, that's fine. Just make sure it's x1 minus x2. Once again, you just have to kind of keep things in the same order. And these were kind of quick, so you just kind of, what do I got here? What do I get? 5 over 3. If it's reducible, go for it. That's not, so that would be my slope. Pretty quick. Anyway, we're gonna keep going here. What do we get for this one? Y2 minus y1 is 5 minus 0 over x2 minus x1, that's 10 minus 5. It's just a quick little simplifying. What's that, 5 over 5? You would simplify that to be a slope of 1. So just as a heads up. So we can plug into formulas for days here, right? We're just changing numbers. It's just getting used to what goes where, and once again, that might be familiar to you from last year. So right now, can you please try 6? Ooh, let's try 7 too. How delightful. Look at, there's variables there. Why not? So can you please find the slope of number 6 and number 7? I just want to do my attendance quick.
Number 6 and 7, you said?
Yes, yeah, 6 and 7. All right, we got beautiful. All right, those shouldn't take too long. I know the variable one, you kind of, I don't know what the heck to do, so let's just check and see what we do. So once again, slope equals, if you need to do some labeling, go for it. Just be careful with signs. Y2 minus Y1 over X2 minus X1. Be careful with those double negatives because they do turn to positives, right? 2 negatives are positive. So that's negative 12 plus 2 is negative 10. Negative 2 plus 2 is 0. Anytime we see a 0 in the denominator, we would say your slope is undefined, which means it is a vertical line. And last but not least, number 7, y2 minus y1 over x2 minus x1. That's 2 negatives. So I just do the same thing I do. If there's variables, so be it. Combine like terms, I get negative 2n over 2 negatives would make a positive 4m. There's that. I can reduce this. I know n and m aren't the same, but I can reduce negative 2 over 4, right? So my final answer would be negative 1n over 2m. Yeah, we're going to still have variables in the answer. Perfectly fine. Why not? So anything, if we can plug into it, you can plug in a number, a variable, or whatever you want. So that was 6 and 7. Did you guys have any questions on those? Okay, and then just, we've talked about vertical lines quite a bit, but just as a heads up, anytime you're talking about a horizontal line, so just as a reminder, horizontals like that, well, that's a terrible idea, but you get the idea. A horizontal line always has a slope of 0, and then a vertical line is like this, that's always gonna be undefined. We talk about horizontal and vertical lines a lot, they just randomly always pop up there. So it's just kind of getting used to that information and all that fun stuff. Ooh, all right, let me see what else we got here. I can't see. Oh, these ones are fun. Ooh, that's exciting. Okay, great. Okay, we can do that. Great. So just a few more, just bear with me for at least a few. So with that slope formula, we can use it if we are missing something, which is gonna be happening in numbers 10, 11, and 12. So once again, a formula we can plug into. Once again, if something's missing, we can solve for it. So that's what we're gonna do here. Each pair of points lies on a line. Okay, so we have a line, great. It tells me the given slope, and it tells me to find the missing variable. So just as a reminder, my formula, y2 minus y1 over x2 minus x1, and that equals my slope, or m equals, doesn't matter. So think about what you have and plug them in. This is x1 and y1. This is x2 and y2. I'm gonna start throwing it in. y2 I don't know, so I'm just gonna leave it as y. Minus y1, which is 5, over x2 minus x1. And in this case, I know the slope. I feel like we're always looking for the slope, but I know that the slope is 4. So m is 4. Our main goal is to solve for this y, so you can only have one thing that's unknown, and that is our unknown in this case. So I'm saying to myself, okay, well, how the heck do I solve this? So I like to kind of rewrite. I'm a simplifier as I go here. So we have y minus 5 over 3 minus 2 is just 1 equals 4. Well, anything over 1 is just itself, right? So it's just y minus 5 equals 4. And I can solve pretty easily for y by adding 5 to both sides. And I got my missing one. So plugging into a formula, in a lot of cases, we're looking for slope. In this case, I know slope, and I'm just looking for kind of a random variable there. So plug in what you know, and then solve for what you don't know. So 11 is same idea. Let's set it up. y2 minus y1 over x2 minus x1, which I'm just leaving as x, equals, I know my slope is -2. Okay. This one's a little different. The x is in the denominator now. I'm not feeling as good about the situation, so let's see what we got. I'm just gonna do that 11 minus 2, that gives me 9. I'm gonna kind of stop here. I'll give you a second if you're catching up. Hey, I have the equation 9 over 5 minus x equals -2. Does anyone have an idea of how I could solve that equation, Christian? Multiply by what?
9.
No, you can't multiply by 9 because 9's in the numerator. Good guess though.
Yes.
5.
No, multiply by 5 isn't gonna help you either. Anyone else have an idea? Well, it looks like people have the same idea. So you can do two things. You can multiply by the entire denominator, which is 5 minus x. Here's what I do, because I think that's kind of a pain. I always just take this side and I make it a fraction. I'm gonna put it over 1, because that's what we call a proportion, and we know how to solve that. So always think about, previous ways we know how to do things. So what I always do is I just make the other side a fraction by putting it over 1, and I can just cross multiply. I think that's a little bit easier. That gives me 9 equals, I would have -2, just make sure that 5 minus x does go in parentheses because you're multiplying the whole thing. And now we can solve for x. What a delight. That would give me what, -10 plus 2x. I'm kind of running out of room here, but you get the idea. 19 equals 2x. So x is going to equal 19 over 2. I'm just gonna leave it like that, you don't have to do anything fancy and then make it a mixed number, I don't care. Oh yeah, that makes sense. What a delight, how exciting. So you're setting stuff up, if you don't know how to solve something, kind of think back to your arsenal there. We can make anything a proportion by making some fractions over 1, and then we can kind of cross multiply and go from there. So number 12, to kind of wrap that up, I'm gonna plug in y2 minus y1 over x2 minus x1, so just be careful because you do have that double negative, equals, it just says undefined. That doesn't actually help me solve anything. So I end up with, okay, well, that's not really that exciting. I have -2 over x plus 2, right, equals. What can I do if that's undefined? What do we know about things that are undefined?
Zeros in the denominator.
Beautiful. I really only care about the denominator. And what that means is over here, if I have a fraction, I just need a 0. I actually don't even care about the numerator at this point. That has no effect on my problem. I'm just saying, the denominator has to equal 0 if it's undefined. So I'm going to take that x plus 2 and set it equal to 0. Because I'm doing the denominator equal to 0, and that comes out to -2. Sounds a little funky, just, like, I don't know what to do. There's a word. And go from there. Let's see. So number 13, and then the back is pretty quick. You guys will work on the back in a minute. Do the points in each set lie on the same line? If I can talk today. To check to see if these are on the same line, you can do a few things. One, you could graph them. We don't really have a graph, so it might not be so neat. So an algebraic way to check is pick 2 points. So let's pick the point G and H. We're gonna find the slope. Okay, I can do that. So for G and H, I would do y2 minus y1 over x2 minus x1. That would give me what? That turns to addition. -3 over -2. So that's just 3 over 2. Then you're saying, well, what about I? We haven't even talked about I. So you just need to find the slope between I and one of these other points. It doesn't matter which one. You can either do G and I or H and I. I'm gonna do H and I. So pick 2 points, find the slope. Pick another pair. So just make sure the one that you haven't picked yet is included. Find the slope. So if I do y2 minus y1, I'm using that as my 2. Over x2 minus x1. That will give me 9 over 6, which is 3 over 2. Since these match, it says, do these points lie on the same line? The answer would be yes, they do. Because I could pick any 2 points and I'm going to get the same slope. What an exciting day. Can you guys check to see if 14, those points are on the same line?
Because it's just social motion. Yeah. All right.
Mr. Schumann,
What's up?
may I go to the bathroom?
Oh, absolutely, go ahead. Okay, guys, yes or no?
No,
It's a no, right? Didn't they come out to like almost the same thing, but one was negative, one was positive?
Yeah.
Okay, man, I remember that from last year. I'm good. I'm done with worksheets. So they come out like very similar, but with the different signs, they are different. So if you think about it, one's going this way, one's going that way. Those aren't the same line. So your answer to 14 would be no. Beautiful. All right, I just want to quickly do those, and I'm gonna have you guys try a few graphies here, and then we'll be done. Oh, look at this. It says independent and dependent variable. That's from last chapter. Find the rate of change. So I haven't mentioned rate of change yet. It's the same thing as slope. So anytime if you do see something say rate of change, you're really just finding the slope. Once again, sometimes we like to have the same thing but use different words for it. I don't know, just to confuse you. Or to confuse everyone in general. So we're talking about the cost of milk. Oh, the cost and then how many gallons. So if I say independent and dependent, my gallons would be independent. And usually my cost is the dependent, right? Because the cost depends on how many gallons I have. I want to find the rate of change. Just think of these as points. It's just when you think of it as a point, your independent is the X and your dependent is the Y. So 3 gallons is $8.85. And 5 gallons is $14.75. Okay, that's pretty easy to think about as a point. And then you would just find the slope. So slope would be, I'm gonna need my calculator for this one. I'll find the difference in my Y's over the difference in my X's. I have no clue what that is, so I'm grabbing my calculator. 14.75 equals, that's 5.9 over 2. And when I divide it by 2, I get 2.95. So when we think about what that means, that's $2.95 per gallon. So I was really just finding the cost of 1 gallon of milk in that case. 16 we'll do in a second. I'm just gonna show you one of these and then you guys are just gonna try a few and we'll kind of wrap it up. So just as a reminder of graphing, once again, something you've done, but it's always good to remind ourselves what to do here. Anytime you graph, you always need to start with a point, so you can never start with a slope. In number 17, I'm gonna start with the point 5.2. Remember, when you do a point, you will go on the x-axis first, 1, 2, 3, 4, 5 from the origin, and then up 2. So you always need a starting point, no matter what your problem. From that point, you do your slope. We say that the slope is rise over run. So in this case, we do need a fraction. I can always put that over 1 if I need to. So from this point, do not go back to the origin, which I feel like some people want to do. From this point, that's why we need it first. You are going to rise 1, 2, 3, and run 1. Just as a reminder, you can keep going. You can keep going 1, 2, 3, 1. You can do it as many times as you please. You can also go down 3 to the left 1. But as long as you have 2 points, you have a line. We're gonna do our best without things. I know mine's kind of cut off, but you would keep extending it as far as you can go. Lines are infinite, so you do put arrows on the end. To remind yourself that the paper stops, but technically the line doesn't. And that's how you graph a line. So number 18, you do the same thing. Apply your point. Remember, if the slope is 0, you just make it 0 over 1. Rise 0, run 1. For some of the other ones, things like negatives, just make sure you're going in the correct direction. If something goes off of a graph, you can always, if it goes up to the right, you can go down to the left. All the other ones you should be okay. Undefined is vertical. Yeah. We'll just kind of see what you remember in the next few minutes. So I would like you to try 16. He's filling 10 envelopes in one, 110. What's the rate of change? You can just make some points. And then can you just do your best? What do you remember about graphing? I'll give you a few. Oh my gosh, I'm not gonna make it today, a second lunch.
There's a couple of them.
Okay, so let's just do a quick look and then we'll be done. So we had just done 17, so 18. Once again, we're doing our best. I'm trying not to contaminate all my rulers here. I'm having mine a little bit smaller, but I'm gonna go through the 0.31, excuse me, 3, -1. The slope is 0, which means I rise 0. I'm not rising, but I'm running 1. So you can do a few if you want, but in general, we talked about if something is 0, that is a horizontal line. So that should be your answer to that one. Number 19, you go to the point -21. The slope is -2/1. We always make it a fraction. So that means my rise is -2, but my run is positive. So we would go down 2 to the right. You can do a few points if you want, but technically you only need 2 points to graph a line, but yours should look something like that. And please just check, negative should always look like from left to right that it's going down. So just as a heads up there. When I go to the point 210, 6, 7, 8, 9, 10. I'm saying, oh, my slope is 4/1. I say, oh crap, I can't go up 4. There's not enough room. Remember, you can write, instead of going up and to the right, you can go down and to the left. Oh gosh, 1, 2, 3, 4, 1. So please make sure you can always kind of rearrange to your liking, whatever works. But if it's, you notice, I don't want you to draw extra graph. I don't want that. I want that thing. So instead of going up to the right, you can go down to the left because that's still a positive slope. It's still going up as you look at it from left to right. So just as a heads up there, so little things to remind ourselves about, well, what do I do if it doesn't fit? And then the last two. -5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, that's 7. The slope is -2/3. The negative is only going with the 2, not the 3. So I'm gonna go down 2 and then to the right 1, 2, 3. Once again, you can extend it a few if you'd like. Technically, you only need 2 to make a line. You could also go up 2 to the left 3. So you can kind of flip the negative, just as a heads up there. And last but not least, -2, -1. Undefined, you just need to know that's a vertical line. So there is no rise or run, it's just undefined, vertical. So please check the problems that we just went over.
Mr. Chairman,
Yes.
did we go over 16?
No.
Oh, no, we didn't.
Oh.
So you would have, thank you, I just totally forgot we were doing that one. So you would make the points 10, 1, 100, 10. Does the rate of change come out to just be 10?
Yeah.
Yeah,
I thought it was minutes to envelopes.
no, it's envelopes per minute.
Okay.
When you think about envelopes per minute, makes sense, minutes per envelope. I guess, if you did it the other way, it would be 1/10, right? Either way. It's kind of a weird variable, so I feel ya. So if you did it the other way, that's fine. I'll be more specific in what I'm looking for. But that's that.